Alright people, here we are. Another exciting lecture on tab. I never know how this is going to turn out in terms of like my actual sounding. I don't want to yell at you or anything, but I guess there's a thing called volume control, but whatever. So we're going to start with one of my, a good chapter. I think this was a fun one to get on after the toughies we've had recently of the immune system and the lymphatic system, which aren't, they're cool, right? But there's a lot of tough stuff in there. That's not the easiest things in the world. I think respiratory is one that's like, okay, this just makes sense. I think in terms of overall functioning. And part one really is the easier one because it's a lot of we're going through some structures, like how you actually break it down, because it's way more than just like, oh, lungs, and like, oh, call it a day. It's more than a slide, that's for sure. But yeah, part two we'll get into more of the physiology and more in-depth on how breathing actually works, which will not be this week, but next week. So this is kind of a fun little, dare I say, breather between some of the tough concepts we talked about so far, and way more interesting, I think. I mean, we all breathe constantly. I mean, like, and you're more aware of that than like your immune system, like fighting off a bacteria. You don't go like, oh, look, fought off another parasite trying to invade in me, or boom, that bacteria is dead. You don't have a running tally of that. But breathing is something you're like, oh, you can feel it. It's something you're much more aware of. So that's why I like it. So without further ado, let's talk about some respiratory systems. Let's get at it. Alright, so the reason why I like this system a lot is, again, breathing. We all have to breathe, and sometimes having a shortness of breath can be symptoms of things, such as something that we're all facing right now. That's one thing to look out for. It's a common symptom, right? Issues breathing, something's happening. It can be, a variety of things that can cause it, but we gotta breathe one way or the other. You can't just float in space without a spacesuit. You'll die. There's a lot of stuff that can affect how you breathe, and it's, my allergies usually make mine, not great, and cold air affects me a good bit, because I have asthma. But it's only really triggered by extreme allergies, which I don't get that often, thankfully. But sometimes, like if I'm like a cat or something, like, oh boy, I need my inhaler, stat. That's actually the old inhaler I used to use, a picture of one. I got a new one that's red and white now. I prefer the old blue color, but whatever. I've had one for a long time. I was first diagnosed with asthma back when I got my allergies. So I was like in first grade, so man, I was a cool kid then. Big old glasses, big inhaler, hooked up to a breathing machine from time to time to make sure I didn't die. I remember I had to use this thing for a good bit to actually measure how much I was actually exhaling, so what my breathing output was. So I'd have to like do it and then like remember the number and tell my mom about it, like, hey, I did this number. And like my doctor told me like the numbers it should stay at. And I had to use my inhaler a lot more then because I was sick a lot, but yeah, you got over it. Now I use my inhaler from every once in a while. Mostly cold air is really what gets me. I don't know. I'll talk about that later. I'll mention it later on. I got a good story there. Me almost dying once. I may have already talked about it, honestly, but I don't know. I don't remember. But anyway, I'll talk about it again later. Maybe in part two. I don't want to burn everything in the first 5 minutes of this thing starting. So yeah, it's good stuff. You gotta breathe. So the main function of the respiratory system isn't a shock, right? Getting oxygen inside the body, so you can actually breathe. So you need oxygen for cellular respiration to take place, and so that's a biology process for sure. We're not getting into any of that. But the point is, you need it to make energy, right? Make something called ATP, which is an energy molecule to be used inside the body. Gotta have oxygen for that. Well, you don't have to. There's anaerobic respiration, which gets by without oxygen, but it's not as efficient. It builds up acid, and it's just not as great. So you ideally want that oxygen. But in addition to that, you gotta get rid of some crap, right? Waste. A lot of these systems are also about getting rid of waste. And so one of these is a buildup of carbon dioxide. So when we're doing our cellular processes, one of the byproducts is carbon dioxide. We gotta get that out. Otherwise, you might have a buildup of a waste product, which is very rarely good. So you don't want that to happen. And so that happens. And when you think about the respiratory system, we'll look a lot at the circulatory system too, because, I mean, it's a key part of it. Like, when you bring this oxygen in, like, bringing it into the lungs is just half the battle. Then you also have to get it through to the body, through all the tissues. And the way we do that is through blood, which we've talked about before, and how, one of the main functions of blood is to carry oxygen around. So, no shock there. But also, another little unsung factor of the respiratory system is, and it's very relevant right this very second, is where we have circulatory system, or excuse me, not the circulatory system, but olfaction, which is smelling, and speech. So, all right, so the process of respiration actually involves a few processes. And so the first of these is actually pulmonary ventilation, which is just a fancy way of saying breathing. So that actual act of breathing, of moving air into and out of your lungs, is called pulmonary ventilation. And so if you think about it, pulmonary, lung, ventilation, movement of air, right? I mean, it's not that complicated of an idea. And this is one of the things that's going to be found as part of the respiratory system. And there's also external respiration, which is the exchange of oxygen and carbon dioxide between the lungs and blood. And this is also part of the respiratory system. So we have those two functions, pretty key things, found at the lungs. But there's more than that. There's also, we have to transport the oxygen and carbon dioxide in blood to bring in the oxygen to give to the tissues and get rid of the carbon dioxide out of the body. So you have a transport mechanism. And this doesn't take place, well, that transport doesn't take place in the lungs, except for the initial point. And then we have internal respiration, which is where you actually have a crossing over in the tissues where oxygen goes in, carbon dioxide goes out of the tissues. And so that's one of the fundamental aspects of respiration. The reason why we do all those first three steps is that last point to get that good stuff in the body, get the bad stuff out of there. So if you break it down, the systems we mentioned earlier, those respiratory and circulatory, well, the respiratory system is involved with the first two actions, while the circulatory does the other. They can't function by each other and fine. They can't do all four of these collectively together by themselves. They have to have both. If you don't have any blood, well then, you can breathe all you want, but you're not going to get anything into it. You're going to die. And if you have the blood, but no lungs, well, you're not going to breathe, so you're going to be dead. So, yeah, you got to have both those suckers. All right, major organs, what we got? Nose, obvious, sinuses, pharynx, larynx, trachea, bronchi, lungs, and alveoli. These are broken down into upper and lower respiratory. If you ever had an infection of some kind, you may be like, oh, I have an upper respiratory infection or a lower respiratory infection. This can actually be pretty important sometimes if you're trying to diagnose a condition. Like, corona is seen as more of a lower respiratory situation. Meanwhile, like a cold or something is more upper respiratory. So if you're like a runny nose or something, that indicates that maybe you don't have, COVID-19. You could, but you also have something else, but that's not one of the main symptoms, right? So that's why you can diagnose those and figure out where things are happening. But upper respiratory, those structures. Pharynx is again right up near the mouth area. So I remember seeing some diagrams in lab. So that whole thing. The sinuses are also near the nose and the actual nose itself, and then everything kind of below that. So larynx is the voice box, the trachea, you've seen that in the pig several times now, and then the bronchi are these little branchings that go from the trachea into the lungs, and the lungs themselves, which is all lower respiratory. Okay, so here's our little person here, carefully cut in half. You see some structures, so you can see all those organs and where they're found. They're not hard. I mean, a lot of these things you've probably heard of before, hopefully. There's a couple weird ones, right? Like the pharynx, like, ooh, what's the pharynx? And the larynx, they sound so similar to each other. I wonder if that was done on purpose. I don't know. Anyway, here is a nice table that breaks down some of these structures and descriptions and their functions. So looking for some quick hits on studying, bam, here you go. Here's more of that table, just continued and further structures found. One of my favorites, the bronchial tree, because it's a tree inside of you. How cool is that? And trees deal with oxygen just like the bronchial tree does. Crazy. All right, so let's look at the first one of these structures, the nose. So the nose is the only part of the system that's actually external. Everything else is an internal structure. And if you think about functions of the nose, well, think about them. Like, what do you think the nose does? It's pretty obvious. One of them is with smell, so it houses smelling receptors. What else does it do? Right, it has the big openings in there, and if you have a clogged nose, right, you can feel those effects. It makes it harder to breathe. So it has the role of respiration. It also helps with moistening and warming air. So it kind of acts like a humidifier inside the body, because that's the air that works better. So like cold, dry air is a little harder on the system than that moist, warm air for being taken in. And also, with nose hairs and mucus, helps filter out air that's coming in, because air can be grody, right? You can have viruses inside of that air, and so you need to have a way to try and pick some of those things out if you can, and so there's a system for that in place. You got pollutants and everything else, just a bunch of gunk. It's gross. Also for speech. So again, if you have a clogged nose, you know you sound different. Like my nose is a little stuffy today. Woke up with some allergy issues, so I mean, like if I sound a little different, well, that's partly why. And of course, smell. And so there's actually a good episode of the Rugrats. It's a great show, by the way. I grew up watching that show a lot on Nickelodeon. It was good. And nowadays, it just seems like it's SpongeBob and a bunch of live action crap. But back in my day, man, let me tell you something. We had the live action crap too, but we had a lot of cartoon shows. We had Hey Arnold, we had Cat Dog, Rugrats, all kinds of stuff. So you're really missing out. But anyway, an episode, the character here, Chucky, not Pinocchio, Chucky, the orange-haired kid with purple glasses. He had bad allergies, so he couldn't breathe, so he had to stuffy nose the entire show. So I always kind of related to that in my own way. But one episode he had his nose cleared up and his voice sounded different and he could breathe easier, so he'd actually be running around a lot more, and he could smell things. So it's amazing how having a clogged nose can really affect you in a lot of different ways. It kind of sucks having a clogged nose like every day, all day. That'd be kind of messed up. I never watched much of Rugrats growing up. I don't really know if that was good or not. It was hit a point where I was not watching like new stuff as much, I was watching old stuff, but anyway, good show. Let me know if you've seen Rugrats all growing up and how good it is. Leave a comment. On the far right is a bunch of snot coming out of somebody's nose. Gross. Alright, this is going kind of long. So, inside the nasal cavity, you got some hairs found inside of there. And so there's a septum. You can see that being divided. It divides this area, so it can deviate a septum, like, deviates from that path. So it's not as great. But is that opening inside of there? Excuse me. I don't know why every time I want to yawn doing this. But there's a bunch of hair inside of there that helps course it out. So that's a thing. And there's mucous membranes that line the rest of the entire cavity. So it's just a bunch of mucus in there to collect stuff with that hair. And the septum divides into chambers. Now we have the conch. So the nasal conch. If you ever think about conch, you may think about the snail, which is the picture on the right side. And the reason why it has this name inside the nasal is because it has a similar kind of structure to it, where it has all these like different ridges to it, like the inside of one of these shells. But during inhalation, the conch serves a purpose to filter heat and moisten the air, while during exhalation, it tries to keep some of that stuff back. So the body's cheap, right? It doesn't want to waste a lot of resources. So if it can reuse things and not blow heat and moisture just, for willy-nilly, it'll do so. And it does so using the conch. And it turns out, I saw this thing recently, where the nose will actually alter. So you had that septum, right? Divides it into left and right halves. Well, which side receives high airflow versus low airflow changes constantly, like every couple hours. And so you may notice this sometimes when you're breathing through your nose, like, oh, one side's doing more and the other one's not doing anything. And that happens, and it just swaps back and forth. And so this is a benefit because it allows one side to always have moist air for breathing, and then it also helps with the slower intake, like air linger in those spots a little longer, so you can actually pick up on chemicals and smell. So play around with that, see what happens. Maybe what's your time, maybe you're 2 hours, maybe you're a 4-hour person, who knows. But that was kind of neat, who knew. Alright, sinuses. If there's one thing I hate, it's sinuses, because I'm pretty sure I got like a deviated septum or something, because like my sinuses are all jacked up from time to time. And I have some bad sinus headaches, let me tell you. Oh man, back in November, I had a real bad sinus headache. I had to leave work early, it felt awful. It was on a Friday too, I was so excited for Fridays. And I hate when Fridays get ruined by awful headaches. It was terrible, it was a bad time. I use a lot of nose spray to try and help with that. I don't know if it does anything, but I don't know. I'll snort that stuff like no other. It's saline, alright, not the other chemical stuff. You can get addicted to that, and you gotta watch out. Or at least your body gets addicted to it, so you develop a reliance on it, and you have to like break the habit. It's pretty crazy. Happened to somebody I knew once. They got hooked on it, and it took them a while to get off of it. And like while they were trying to wean themselves off of that nose spray, they had a stuffy nose and felt terrible. So watch out for them nose sprays, yo. The functions of the sinuses, besides annoying me, are to make the skull a little lighter. You know, why not lighten the mood? Make it a little more uplifting. It does so by having these open air cavities, right? It's not just dense bone in those areas. They also release mucus. Yay! Who doesn't love some mucus being secreted and released? And then also with the air. So it's another structure that's warm and moist in air. So we got the conch that does that, and then we got the sinuses, and we got those mucous membranes too. So all those things, you know, a lot of structures out warm and moist in air. So it's a thing. So here's some of those structures again. So you can actually see the conch outlined there with what they're doing. And then, you know, air comes in, it comes out. You don't see the septum because it kind of defeats the point of the picture. But it's there. It's there. All right. Pharynx. The pharynx always, I'm a big fan of this name because it sounds like an ancient Egyptian type thing, you know, like the pharaoh, the sphinx. What if you had a pharaoh and a sphinx and you cross them together? You get pharynx. That's kind of what happened here. And it's not like a crossing of a couple of things. But so this is a tube that goes from the back of the head down. And so the main function is to connect your nasal cavity with your mouth. And you're in your mouth to the larynx and the esophagus. So that's a couple different structures there. So you've got air coming in the nose, air coming in the mouth, food coming in the mouth. You got a food tube in the esophagus. You got the larynx, which is all about voice and leads down to the trachea. So it's pretty crazy. And this is composed of skeletal muscle, and this is pretty important. So you can actually have some voluntary control over that sort of thing. And there are three regions, of course. You have the nasopharynx, the oropharynx, and the laryngopharynx. Now these sound super complicated, made-up garbage terms. However, the naso deals with the nasal cavity area, the oro deals with the mouth of the oral cavity, and then the laryngopharynx deals with, of course, near the actual larynx, right? So it makes sense. But the pharynx, something I want to keep up with these different structures we talk about, is what do they carry? Do they carry air? Do they carry food? Do they carry liquid? What do they carry? Well, the pharynx carries all three. It carries food, it carries air, it carries liquids. Because air comes in, food comes in, liquid comes in. They haven't branched off yet. And so there's, again, those structures highlighted. Naso, oro, laryngopharynx. That's like a complicated name. Alright, so let's do a quick little recap. We'll make this quick. So functions of the respiratory system. What are the functions of the respiratory system? That's something you should pretty easily know. But it's more than just breathing in air, right? You got to give me more than that on any sort of test or anything. So you got to mention, you know, that it does breathing maybe, or not breathing, jeez. Smelling. Let's see what else it does. It does speech, right? It does some speech stuff. It also gets rid of waste, right? So a lot of stuff. So I'll get those down. Something else. The four processes. Now, what are the four processes of it? So this goes back to the process of respiration. Okay, so you have pulmonary ventilation, which is air going in and out of the lungs. You have external respiration, which means air or oxygen is going from the lungs into the blood, and carbon dioxide is going from blood into the lungs to get exhaled from the body. And then you have transport, which is where that newly intaked oxygen goes to your tissues. Then you have carbon dioxide, releases a byproduct of chemical reactions of the body. It is carried from those tissues to the lungs. And then you have internal respiration, and that's where oxygen will enter inside the tissues, and then carbon dioxide will enter inside the blood. This is a pretty cool GIF. I hope this shows up on your pictures. I don't know how well it's going to show, but for me, I'm just seeing this GIF. If not, I'll try and release it or something so you actually see it in form. But so you have this this action here of this character Violet from The Incredibles 2, which The Incredibles is one of my all-time favorite movies ever. And it's weird because I never saw that movie in theaters. I could have. I wanted to. I just didn't. I didn't go to the movies a whole lot back in 2004 when that came out. I just wasn't into going to the cinema as often. But we have a character drinking water, right? Violet in this case. And then she sees a boy she was supposed to go on a date with, but then he forgot, and then forgot who she was, which, man, you hate when that happens. You know, don't want to get stood up, but I mean, they forget you even existed. That's pretty terrible. But then she's flabbergasted at seeing this individual at this place. Her eyes get all wide. You can see the constriction of the pupils. And then the water she just drank rushes out of her nose, right? How is this possible? This is a phenomenon you've probably experienced at some point or another, right? You drink a liquid, you do something, and then it rushes out your nose. I haven't done that in a very long time, but I have had it happen to me, and I'm sure there's something we all have. So this is something you should be able to explain, like how this works. So, and it's easy if you think about it in terms of the pharynx. You have this fluid that comes into the mouth, but then it enters the pharynx, the oropharynx, but it's easily connected to the nasopharynx. So when you make this sort of response here, you're going to exhale air, right? So it's like, you know, like what am I saying here? And when you do so, it drives that fluid up and then out the nose because it's the open cavity here. And so it pushes it out like a little water volcano or a drink volcano. And then it just rushes out. And it's because the back area of the pharynx is connected. It connects the nasal cavity with the mouth. So they're connected together. So sometimes you can like taste stuff that you're smelling kind of weird. Sometimes that made me in lab. Some of those nasty things will cut open. It's like, oh, gross. I just taste it sometimes. But, you know, same kind of deal. Anyway, that's neat. Okay. Let's talk about the lower respiratory system now. So with the upper, you know, we'll cover those structures. Talk about the lower. And this leads us to the larynx, the trachea, the bronchi, and lungs. I like bronchi. That's a cool name. Bronchi. Dr. Bronchi. I don't know. That's a ring to it. Professor Bronchi. Sir Bronchi. Madam Bronchi. I don't know. But even dog bronchi or a fish, that'd be kind of fun. Anyway, the respiratory zone, lower respiratory zone, the system is broken into two spots. You have the actual respiratory zone where gas exchange takes place. And so these are small structures. And so you can see a picture of it on the right side. Those structures where you actually have respiratory bronchioles, which are very, very small bronchioles. And those lead into alveolar ducts, which contain alveoli, which sounds like a pasta, but it's not. Instead, it's a very important structure for gas exchange. And then we have the conducting zone. So the conducting zone is the one that actually carries gas to and fro. So no actual gas exchange takes place. This is just, you know, the network that carries the gases to those spots for the gas exchange to occur. So that's how that happens. So it includes all the other structures. So the bronchi, the trachea, the larynx, all those things. The pharynx, right? Well, not the pharynx. That's an upper respiratory structure. But the trachea, the bronchi, all the terminal bronchioles, all the branchings there. And during the way in the conducting zone, a continual theme is you clean the air, filter it best you can, you warm it, and humidify it to make it moist. And so it helps prevent any of these structures from drying out and prevent damage to the system. So you don't want that to happen. All right, larynx. So the larynx is the voice box. And we have it, you'll see it in the pig. You should have seen it in the pig. Yeah, we did the dissection. It was before spring break. Man, that feels like a long time ago. But yeah, you should have seen this thing. It's a nice little, decent sized little box. And so it continues on and opens up into a channel and it's continuous with the trachea. So as a structure, there are some functions of the larynx. One is provides an open pathway for air to go through. And then it also helps to move air and food where it needs to go. So one of the functions of the structure is to make sure food does not get in the windpipe into your lungs or water get in there, because then it's hard to do the job of, breathing, gas exchange, respiration. If you have a bunch of food in there, and if you've actually, something's got in the wrong pipe, right? So, you want to avoid that. Sorry. Yeah. Also involved with voice production. So there's actually a cool video I'm going to post, a couple of them, and you can see the vocal folds inside of there and how they can move during actual speaking, so voice production. So it's a thing. And so one of the things that comes up is many people have had cats or a feline connection, and so you think about cats purring and then lions roaring. Well, one of the main reasons why there is a difference between them is there's a difference in sort of connective tissue they have that deal with the larynx. And so there's a ligament that's needed to produce the roar, and cats don't have it. But lions, tigers, and jaguars and leopards have it, so they can do it. So by having that ligament, it changes the shape of those vocal folds and allows them to, just do what they do. so that the vocal folds themselves don't get stretched and like moved in a way when air moves through them. And so it's a little different. So it's just kind of cool. So it's all about those sorts of things, like random small changes, like a ligament being different, can lead to a very deep, scary roar versus a nice soft purr of our house cat. So another thing coming up with the larynx are cartilages. Gotta talk about cartilages. A few types, and these are also in lab. Make sure you know them. So the thyroid cartilage, and so you can see that prominent in the picture where that's found. This contains the Adam's apple structure. Then you have the cricoid cartilage, which are the ring-shaped cartilage found just below that. And then, of course, you have the tracheal cartilages that line the trachea. Another structure found here is the epiglottis, and you can see that labeled in the picture as well. So, good old epiglottis. What does that thing do? Well, the epiglottis is elastic cartilage, so not hyaline, yay. And it has it moves to prevent things from going inside the actual trachea. So this flap can move and prevent food and liquid from entering inside your respiratory cavity. So you can change that, or you move it. You have control over it to actually prevent you from dying while drinking water or eating food, right? But if you get that thing down the wrong pipe, that means maybe try to breathe or something when you're drinking, and then fluid went inside of there because the epiglottis moved and didn't cover that spot anymore. So that happens. Interesting enough, it also has taste buds to it too, so that's kind of cool. But main function: prevent food and liquid from going into the trachea, because that's bad. You can't breathe with junk in there. And so that's where that inlet is that it covers during swallowing, is it covers that spot, so none of that stuff can get inside the actual trachea. And so here's a picture showing some of those different things you can maybe see on a structure. See what you see. So here's a picture of vocal folds in different positions, and one where it shows in a closed opening, so the glottis is just a closed opening, and then you have the glottis where it's open, so that means the air can pass through, and then when air moves through, it causes those vocal cords to fold and move and vibrate and just move in different ways, and that causes sound. Again, check the videos out, they're really cool. Now, one thing you may have heard of before is laryngitis, and this is where the vocal folds themselves are inflamed. And so they swell up, and that makes it harder to speak, so it interferes with their function because you've changed their structure, and it causes hoarseness, so you really can't speak as well, and your tone changes, so it's just harder to speaking, and so usually you have more like a whisper, and you also have a swollen tissue, and it kind of hurts, right? So it's kind of rough. And laryngitis is most often caused by viruses, but it can also be due to overuse of the voice. Usually in the beginning of semesters, especially after the summer, when we first get back, I have to talk a lot when I'm not used to it, man, my throat goes. And so it gets real irritated. So I don't get full-on laryngitis, but I definitely have had irritated vocal cords a good bit. When you talk a lot, it's, you're not used to it, which I don't really talk a lot when I'm home by myself, because I'm going to talk to the wall. I talk to my dog a bit, but she doesn't say much back. But you still get that irritation. It's not the same because it's in rapid succession. Also, dry air can cause it, which I end up breathing a lot of dry air somehow, some way. If I was a tumor, I can cause it too, which that's great. But yeah, so there's some pictures that you can see inflamed vocal cords and normal. Change structure, change function. All right, let's pick this up. Trachea. So, big tube carries air into the lungs. That's it. It's got covered with cartilage, and that's key because it keeps it open. Otherwise, it would close. So you need those cartilaginous rings or other structures to maintain them and keep them open so air can pass through. Like the esophagus, which is different and actually fold flat until food passes through it. The trachea has to be open at all times because air by itself wouldn't be able to push through the tube and open it up and widen it. So you got to have cartilage for that structure. And with the cartilage, with the trachea, I didn't mention this. So one thing you should look up is a tracheotomy. What is a tracheotomy? And how does that relate to possible medicinal purposes? So some of you probably seen on shows like Grey's Anatomy or something, but it's not only done on that show. But it's a common procedure that can be done to deal with breathing, right? So think about it. So look up that stuff. Why is it useful? Why would it be used? What circumstances is it relevant in? That sort of thing. I've actually done one before. I did one on a rabbit in my physiology class that I took. And so we actually worked with live animals. And so the TAs would have to go through and begin like the process of getting them ready for lab. So yeah, that was interesting. But yeah, I actually did it. I was the one in my group that volunteered to do it. And you know what? That rabbit died, but not because of my tracheotomy. I think it was perfect. So I crushed it. Well, not literally, of course. Then it would have died from not being able to breathe, but that's not why it died. I did that tracheotomy well. That was crazy. That was a long time ago. It was over 10 years ago. Anyway, the trachea wall. You got to cut through structures to get through it if you want to open this joker up. And there's 3 layers to it. There's mucosa, submucosa, and adventitia. Main thing is you want to keep up with the layering of them. Goblet cells, which makes mucus, are found in the mucosa layer, right? Near where the cilia are. That's important to remember. The cartilage is found in the submucosa. That's good to know. I think adventitia is just the outermost layer. That's good. Alright. And there's those 3 sections zoomed in again. Here's some of the cilia found in there. I find it gross looking in this case. I don't like the idea of these weird strings being exposed on my throat. I find it disturbing. I want to cut them all off and make it nice and clean. But unfortunately you can't do that, and you might die if you do. So, I don't know, you won't die. No, I don't think so. It would be kind of hard to get gunk out of your throat though, so it's not fantastic. But yeah, I'm not going to do it. I'm going to leave them there. They can't see them anyway. Okay, so if you do lose your cilia, you won't die initially, but it does make it harder to get gunk out of the lungs, so it's a harder time. So one of the things you see this cilia disappearing with is with long-term smokers. So it ultimately destroys that cilia. There is no cilia, so you can't get all that gunk that jumps into the lungs that doesn't be there anymore, like mucus, out, so it makes it harder, so you have to cough more to get that crap out. And so in that case, I mean, they need to cough. So it's not like an annoying thing, oh, I should take medicine to prevent it. It's like, no, you need to cough to get that crap out of there, otherwise you're going to have problems breathing. Alright, so don't do that. So, yeah, destroy cilia, you're going to have a bad time. So another thing that comes up is if you have an obstruction in the trachea. Sometimes you have people eat food, right, and then the next thing you know, they choke. And it's like, oh no, I'm dying, I can't breathe. Well, obviously the food shouldn't have gone down there in the first place, but things happen, right? Life happens. And so the Highland maneuver is actually trying to get that thing clogged out from the trachea, so it's clogged. And the issue is that thing is where it should not need to be, and it's blocking airflow. So then you try and use the lungs to try and expel the air that's found in there to pop the food out. It's overall pretty simple to do, but I've never done it. And I mean, I could probably figure it out, but if you do it wrong, it can be very not great. But it can lead to some broken ribs, or at least cracked ribs. So, but yeah, it's overall, I heard, pretty easy thing to do. Maybe somebody in the comments who's done it before or have taken classes on it can enlighten us. Alright, so recap, you want to be able to do these things. What are the lower respiratory zones? So you want to be able to differentiate between upper and lower respiratory zones, what structures are found there, what are their functions. Within the lower respiratory system, what are the zones? So respiratory versus conducting. One is actual gas exchange, one carries air. What is laryngitis? What does that have to do with the structure of the larynx? Tracheal wall layers, right? Mucosa, submucosa, adventitia. Mucosa has the mucus and cilia to get crap out. Submucosa has the cartilage, adventitia, outermost layer. Alright. I don't want these to go super long, so I apologize, but it is what it is. So overall, it's not that bad, right? So the bronchi, the lower respiratory structure. And so here, air is going to go through a lot of branching. As you can see in this picture on the right, like there's a lot of branching that happens once this bronchi emerges from the trachea. And so this is for the bronchial tree, all these divisions. And if you look at it, you can kind of get a feel for it because it kind of looks like a tree. And so the top right is the picture of what it looks like in the body. Then I flipped it, and then that's what it looks like if you want to think about it in terms of a tree. And then the bottom left is the live oak, Quercus virginiana, and it looks like a tree. And they're both involved with oxygen. Like, how crazy is that? So it's insane. And so eventually you have those conducting zones. So the bronchi are one of the main conducting zone structures, but they eventually give rise to respiratory bronchioles, which are involved with respiratory zone functions. So they lead and blend in to eventually transition into the respiratory zone structures. Alright, so the trachea divides the right and the left bronchi, so the primary bronchi. And so the right one's a little wider, but shorter, and just how it goes. Then the left, so you actually see that in the picture there. And so each one of these enters a lung, that's why you have 2 of them. And so then these are broken down into secondary bronchi, and then where you have 3 on the right, 2 on the left. And so, okay, now we're getting some differences there, different branchings that occur. And so each one of these lobar bronchi corresponds to lobe lungs, so that's why they get that name. So there's 3 lobes on the right, 2 on the left. So we have 5 lobes. Remember that fetal pig's got 7, right? 7 lobes in the fetal pig. Okay, so each one of these lobar bronchi, once you get one of them suckers, they branch off into tertiary bronchi. And so these are bronchi that will just keep going and going and just dividing and just branching. They eventually get so small they become bronchioles, where they're really small, less than 1 millimeter. And then they keep on going, and you have terminal bronchioles, which are the smallest you can get. Look how small they are. And these are the ones that will lend into the actual alveoli type structures near the end. And so there's the schematics. You can see it broken down between lobar bronchi and then all the way down to the super small. Well, the smallest it shows. It won't show the super small, but it'll show some smaller ones. It'll at least get you down to tertiary. So the conducting zone itself, so from bronchi to bronchioles, as you move down that system, structural changes occur. This isn't too unlike the blood vessels. We looked at, changing from arteries to veins and all that stuff. Like as you move through the blood vessels, the wall structures change. Same deal here, really. So the cartilage rings eventually go away. They get kind of smaller because it doesn't need as much strength to hold them open. And then eventually, once you get to the bronchioles, you just don't even have cartilage entirely. You just have elastic fibers, which are enough strength to hold something that size open. So it's just so small, it doesn't need like a very strong piece of cartilage to hold it open. And then also, the epithelium changes. And so you have pseudostratified initially, making it the mucosal layer. And that eventually gives rise to cuboidal tissue. So you kind of see a change in the epithelial types there. And then as you get closer and closer to the end, you also see less cilia and less mucus-producing cells. So those are a little broken down and not as common near the terminal bronchioles. And then you've got smooth muscle. So the amount of that actually increases. So you see an increase in smooth muscle. And so what this does is it allows bronchioles to provide resistance. So somewhat much like the blood vessels did, if you have more smooth muscle, you can actually deviate and control where they're going to go. So that happens here. So it allows you to control that and pinch it down and determine where air is going to pass through. So where air will travel. So the smooth muscle helps specify where air can go in these different systems, depending on what room's available, in those bronchioles. All right. So within the respiratory zone, so this begins where the terminal bronchioles lead into respiratory bronchioles, and that leads into alveolar ducts, which goes into alveolar sacs. You can see that in the pictures here. And so these alveolar sacs contain alveoli. Alveoli, again, one of the coolest things. I've always loved raviolis as a food. Alveoli remind me of that. So tons of positive memories associated with raviolis. So alveolis, I love it. It's such an awesome name. I would definitely have like a dog or like a pet. Maybe not a dog. That's long term, but like a fish or something. Alveoli. I go for it. Why not? Why not live a little? Call that thing an alveoli. Be different. And so there's a ton of alveoli. So you have hundreds of millions of alveoli. And this is most of what's in your lungs. And this is used for gas exchange. So you have alveoli breaking down or disappearing, which can happen in some diseases. Well, then that's going to affect your ability to actually breathe in and have gas exchange occur. So it'll damage it. So alveoli, you have to have those for actual gas exchange. And then one of the most important structures we'll talk about in the respiratory system. That's like the main, it's like a neuron in the nervous system. It's a big deal. Alveoli is very much that respiratory system. You gotta know what alveoli are and why they're important in their role. They also kind of remind me of grapes. So I'm a big grape fan. Growing up, I was a green grape man. That was always my go-to for grapes, was green grapes. Then I transitioned. I don't know what happened, but I tried some red grapes, or I don't know, whatever color they are, purple grapes, I don't know, something. But I became a big fan. Like, I was like, wow, man, like, I can't believe I didn't have these before. Now, I'll eat a green grape now, but I'm very much in the red grape camp. That is where I'm at. So whenever I buy grapes these days, I get the red grapes. I don't know why. I don't really remember what the difference is taste-wise, but I don't know. I just like them a little more. It's very unusual. I'm also a big fan of raisins, which are made, I guess, from red grapes, because they kind of look like, you know, red grapes all smushed up. But golden raisins, I think, are made of green grapes, or at least, I don't know, it makes sense, right? And those are delicious, too. I'd highly recommend some golden raisins. If you've never had one before, and you like raisins, or at least kind of like raisins, like, get you some golden raisins. They're fantastic. I bought some recently, and I'm pretty sure I ate them all. But I don't remember. Oh, man, I'll buy some golden raisins. When I get done recording this, I'm going to go see if I have some golden raisins I can eat, because I'm totally in the mood for a golden raisin now. Man, raisins are good. Big fan of raisins. Anyway, and raisins are like alveoli, you know. You get a lot of them, and you gotta have them. Here's a zoomed-in picture of the alveoli and their structures. I love the way they look, you know. It's like little beads on a string, you know, just hanging out, covered with blood vessels, so gas exchange can occur. Boom! It also looks like, if you ever watched like those horror movies with monsters in them, like, have those eggs everywhere, that's what this kind of looks like to me, too. It's like evil eggs, some evil creature trying to take over the world, and it's just sneaking to it, like, you know, it's in a cave, right? So you sneak in there with, like, the crew, the main team, and their flashlights around, like, hey, what are these things? It's like, gee, I don't know. And then somebody goes over there and hits it, and they all start popping, and then, like, boom, you have a swarm of young monsters going around trying to kill everybody. You lose, like, half the team, other ones survive, and it's crazy. It reminds me, I think that happened in Cloverfield. I don't remember. I only saw Cloverfield once, and that was in theaters. I never watched it again. It was okay. But that was, took the world over when it came out. A lot of hype about it. And the monster. It's pretty cool, pretty dark. I don't remember really what happens in it, but I also remember in Godzilla 2000, which, whew, that sucked. That one had like Godzilla with a bunch of eggs in it or something, too. And there's some other ones that are horrifying. Here's a slide showing alveoli. And so we saw one of these in lab, right? You can actually see the bronchioles, how cute, and the alveolar ducts, even though our slides didn't really like this at all, but, you know, hey, that's nice to know what it could be. In alveolar sacs, we have, like, it's a bigger area with much of alveoli in them. So, cool. Okay, so there's the membrane. Okay, there's a respiratory membrane. And so this is a barrier that consists of alveoli and capillary walls right next to each other, alright? Because the main function of alveoli is gas exchange, which means blood has to be real close to it. That membrane between them is super thin, and that thinness helps pave the way for diffusion to take place of these gases across the membrane. So having that thin structure with, let's see if we remember what the tissue type is, because hopefully you do. It's one of my favorites, and it was really cool, but yeah, super thin. And so they're walls, alveolar walls. They have simple squamous epithelium, right? And so a very thin type of tissue. And there's a single layer of that surrounds the alveolar walls. And so single layer is crazy, but that shows how thin it is, so a gas exchange can take place. And this is most of the surface, and it's composed of type 1 alveolar cells. Okay, type 1 alveolar cells, most numbers one around the membrane of the alveolar walls, used for gas exchange. But there's also other types of cells called type 2 alveolar cells, and these release surfactant, and so this helps prevent the collapse of the alveoli. So it helps reduce surface tension in those, which helps lungs function. And so it helps allow for the actual lungs to actually, the alveoli and the lungs themselves, to be able to move and expand and then shrink back down. So it keeps up with the compliance of the lungs and greatly reduces surface tension, which allows those movements to actually occur and then helps prevent and allows for the lung to actually inflate easier. So if you don't have type 2 cells, you can have some issues long term. And so this on the bottom right is a cool little organism. It's called a little flatworm, called a little planaria. It's pretty cute. And so this is an organism that is a super thin form as well. And so it has, it's not very thick, so it's very flat, hence the name flatworm. So it actually performs diffusion across its cell membrane, and that's how it breathes in its environment. So it has a very thin outer layer to its body, so the outer lining of it, and that is with purpose. So it's actually what gas exchange can occur with its environment. We don't have that, obviously, right, because we have thick skin, gas can't get through as easy. But these guys, they have that adaptation where they're just super thin membranes around them so gas can get across. So the same principle, needing diffusion, so you have a thin tissue layer to pave the way for that and allow it to take place. You can find it all over the place. It's a very simple concept. So definitely you have it here in the lungs. Alright, other things you have are with the alveoli. So you have, it has some elastic fibers to it that get the ability to stretch and expand. Also pulmonary capillaries to keep them alive. There's also pores that connect them with each other, so you have some sort of connection between them, and helps equalize the air pressure in the overall lung. And in case you have a block in some way, air can move through, doesn't just get caught in there permanently. You also have alveolar macrophages, and so these are similar to what we talked about the immune system. So these will actually roll around. Sorry, I should really pause this thing when I do that. I'll get better at it. So these things will roll around and go through and just break down stuff. And so prevent, things from getting established. Or it tries its best, right? Because things get established anyway. But it tries its best to prevent so. And you're actually, one of the purposes of cilia is to get rid of those dead macrophages. And then you eat them and process them. So that's pretty crazy and disturbing. So next time you have a mild hack, maybe that's what's happening. You get some dead macrophages you're swallowing down, so it's pretty odd. Yeah. So the alveoli, here is a nice little breakdown showing you the blood vessels on top of them. So you got those capillaries where you have gas exchange taking place over the alveoli. And so here they're zoomed in. This is a model. You also still in lab, make sure you can find these same structures on it. But they have the different types of alveolar cells you can have. With gas exchange, this is an alveoli, of course. You can also have the capillaries where they're at, and then also the wall where gas exchange takes place. Alright, so another recap. You should know what bronchi are, how they're divided. Bronchi, big conducting zone structure. The order of the bronchi, which one do they go in? You have the two that branch off, then you have the lobar, then you have the tertiary, which is lined up with segments. As you move along the conducting zone, the walls of those structures change, right? You start to lose cartilage, you lose the mucus-releasing cells, you lose cilia. The respiratory zone itself, the features that it has, so it's trying to, has alveoli in it, it's trying to absorb gases. It's also got elastic fibers in it to hold itself up instead of cartilage. The actual site of gas exchange is specifically alveoli, so you have to be able to say alveoli. There's a couple different types of cells. The big one where gas exchange takes place is type 1. Type 2 is the other one that releases surfactant, which prevents the whole thing from collapsing on itself. So both pretty important, I would say. Alright, real quick, gross anatomy of the lungs. What we got? What is that gross anatomy? Is it gross? I don't know. Let me know if you think it's gross. But I don't think it's okay myself. It's alright. It's not bad. So the lungs themselves, they filled up most of the thoracic cavity, except for the part where the heart is found in, it's the mediastinum. You have the apex of it, which is deep to the clavicle, since it's the top part. The hilum, this is again, we talked about this with the spleen, we'll talk about it again later on with the kidney. This is where blood vessels will exit and enter the whole thing of the lungs, also where the bronchi go in. The lymphatic vessels, right? You can't get rid of those stupid things. And the nerves, so you can feel pain if something's going on inside the lungs. The left lung has two lobes called superior and inferior. They also have the notch where the heart fits in, so they actually have, that's where the heart goes in, which is pretty exciting. It's just fun. And then you also have the right lung, which has superior and inferior, but also middle, because they got real lazy and say, ooh, what do we call this thing? I don't know, middle. I was like, okay, we'll call it. Let it go. Let it ride. So cool. Little pouches. Alright. This guy, this is a picture of his lungs. It's pretty fancy technology we have with those little x-ray cameras to get these pictures. All for you. all for you. You can find those structures on here. So the different types of loads we have, 2 on the left, 3 on the right, the cardiac notch, apex base, all that sort of thing, diaphragm. And here's another version of it, which is a very disturbing picture of where somebody was cut off. They were using the guillotine, but they just moved them up halfway up a little bit so you could see their lungs. Weird. But you can see the lungs, all the bronchi coming in, all the blood vessels that come in along with that. It's just kind of an odd view. That's honestly why I leave this thing here. I think it just looks weird. Alright, so while the lungs are broken down in different lobes, those lobes are further broken down in these segments. There's 10 of them on the right side, and then 8 to 10 on the left. It varies a little bit. And each one of these, each lobe has 10 of these. So there's 30 on the right, and then between 24 and 30 on the left. Or, excuse me, 16 and 20 on the left. So each one of these segments has its own blood supply to it, and bronchi. And so if you have like maybe a patient who has like a bad lung segment, you can maybe go and remove these individually and keep everything else intact. So it's kind of cool that it does break it down in this way. The fish you see here is called a lungfish. And so they're actually a really cool fish because they have a lung. They breathe air like we do. So they're actually really cool organisms. There isn't that many of them, in the world. There's only a handful of species. There's Australian, African, and South American. And so I forget which one this is. I think this is African. But they're really cool. So you actually see them go up and they'll breathe air even though they're in the water. They're really funny little fins. They're more closely related to us, to tetrapods. So they're kind of in that more pathway, along our way. So they're cool. If you ever see one, check it out. They're really awesome. I used to see one in the lab at Georgia Southern with the grad school. They had one in a little tank. It was a fun little thing. I had to go down there and saying hi, asking him how his day was going. It was fun. He didn't say a whole lot, he would burp sometimes. You knew he was saying something back at you. He had your back. You'd always count on that thing to keep a secret too, which is good. So, lobules. And so these are the smallest subdivisions of the lungs. And so that you actually see with just the eye without going into microscopes or anything. These little hexagonal segments, and these are further served by bronchioles. So the pattern we have of the lungs is it keeps smaller and smaller breaking down, and they're served by the smaller and smaller branches of the bronchi. We have like the lobar bronchi that serve the lobes, and then segmented bronchi that serve the segments. Then you got the more bronchioles that serve the lobules, right? So it's just this continual progression of just getting smaller. And the point of that is so you can get so small with house those alveoli to maximize surface area for actual gas exchange. Lungs are mostly made up of alveoli, obviously, for gas exchange purposes. Come on now. And so the rest of it's kind of just elastic tissues, so they can expand and change shape a lot, which is great for the functioning of the lung. And so here's a disturbing picture of a bronchial tree cast that was done. So this means they took somebody's bronchial tree and then injected it with latex. I guess they died. And then ripped it out of them, and this is what we got left. So it shows you the fine branchings that exist within inside the lung. Looks cool. Looks like coral or something to me. But it's a bronchial tree. I like to get one of these and put it outside on my patio or something. Be like, ooh, that's a pretty tree you have. What kind is it? Oh, it's a bronchial. Ooh, I never heard of that tree. What species is it? A human. It's in you, dummy. And then just walk away. That'd be kind of fun. Alright, so now we have pulmonary circulation. And so this is another actually lungfish in the bottom right. I forgot the species. But I'm pretty sure this is the one that's from Chicago. It was a folk hero called Grandad. It died recently. So don't go to Chicago to see this thing. But it was there for a long time, since the 20s or something. They think it was over 100 years old. But yeah, that joker was old, and kids would love it. They go around and see the little fish rise up and get a drink of water, or not a breath of air, then go back down. People got married in front of this thing. Granddad was a big deal in the Chicago area. So if you're from Chicago, have you seen Granddad? Let me know. I'm curious what your stories are of this crazy old fish. But if you want to study fish, you're going to be an ichthyologist. So there you go. Something for you to know. Could be on Jeopardy or something, Watch Jeopardy, stimulate the mind still. But anyway, pulmonary circulation is when we actually have the heart to the lungs, but in this case you're carrying blood from the pulmonary trunk, right? It's deoxygenated blood, and it goes up to the into the lungs to get oxygenated, then it goes back down to the heart via the pulmonary veins to get pumped throughout the body. Those capillary networks are involved in all this whole thing to make sure this happens. And the veins carry it back. And this is a low pressure system, but it has a lot of volume to it. So low pressure is key because otherwise it would burst the vessels in those capillary beds. Like it doesn't go very far, so you don't need a lot of pressure. And then it's just going into capillaries, we want low pressure anyway, right? So like, but there's a lot of volume because you want to get all that blood oxygenated up. So that's the system. All right, so this is the bronchial circulation. So there's the pulmonary circulation, which is the one that actually puts oxygen inside the blood. This one keeps the lungs alive. And so this provides oxygenated blood to the lungs themselves. They're tissues, right? They need oxygen too. And, you know, they're not using up what they're taking in. You know, they give some to the heart, and then they get some out of that. They get a cut of it. All right, so they give 80% for the body, and they get 20%, you know, cut to keep them alive. And these are round, so they supply all the different types of tissue here to keep them with oxygen, to keep them. And then nearing the end here, pleurae. And so this is a membrane that surrounds the lungs. We've talked about these a lot now. We talk about one around the heart too. But you have parietal and visceral, of course. Parietal it surrounds the outside, visceral surrounds the more organ part. There's fluids in between there that can get infected, but you have to have it in this case with the lungs especially because it allows for surface tension and overall kind of lubrication of this lung that allows for it to expand and recoil back down, which is key to its functioning on the lungs. Otherwise you would have some rough times. Animal on the bottom right is a vampire squid, so it has flexibility in its own self. We're going to expand its body, so it's a cape that it has for its tentacles, its arms, and then it has those little spines coming off, so it'll actually look intimidating to predators. So they're like, oh, look at this messed up looking thing, making this weird mouth at me. I'll go away. So lungs, vampire squid, the same thing. And then we got this thing, again, that cut open photo again. You can see the pleurae. And if you have inflammation of those, it's pleurisy. It's kind of rough and kind of just, oh man, it's painful. You get fluid on there. If you get fluid buildup on the lungs, that's not great. But something you hear every now and then though is like, oh, you know, painful breathing, fluid on the lungs, right? I've heard that a few times. Not with me, but you know, with other folks. And then we have fluid leak, and so you can also have other fluids accumulate in there. So blood can build up, and so you can kind of drown with your own blood in these areas. So it's because you have a leak that comes up, and so all this extra fluid oozes out, and so it can cause some problems. So even one of these can even be a sign of heart failure, which is pretty interesting and neat. So yeah, that sums up respiratory part 1. Next week we'll do respiratory part 2 and digestive part 1. So this is kind of the structures. You want to make sure you get very familiar with all those structures, what functions they are, how to sort them, you know, what they do. Because next time we're going to use all these terms we just picked up on and use them when we talk about the functioning and the physiology about how this thing works and how air actually moves in and out of the lungs. So yeah, all right, that was it. I hope you enjoyed. Remember to hit them forums up, all right? Talk about some questions. If you got questions, hit the forums up. Share them with everybody. Anyway, that's it. Until next time, peace.